Phil's Science Lab, sponsored by ESB's Generation Tomorrow programme, supporting initiatives that help young people develop key skills in science, technology, engineering, arts and maths.
Yes, it's Phil time. Are you looking for an activity to entertain and educate your kids this morning? The science guy, Phil Smith, is back, and today we're going to out of this world as we explore the science behind force. Morning, Phil. What experiment are we testing today? What have you got lined up for me? Got a pair of scissors ready to go?
Good, and yes, obviously safety first. Do not start running around the studio with the scissors. What we're going to be doing today is we're going to be making little rockets, and we're going to look at launch angles, but force as well. So there's a bit of crafting with this, a bit of dexterity, but also a little bit of maths at the end, which is nice. No. We always want to show that maths is nice and practical. So yes, the first thing to do is you should have a sheet of paper and a scissors. Gotcha. Yes, we'll be careful with the scissors. And I just want you to cut a strip along the long side of the A4 sheet that's about 2.5 centimetres wide.
Okay, I've just guessed 2.5 centimetres, so I'm
okay,
ready for your first problem. Gotcha, yeah, one strip, yeah?
One strip. There are spares cut, just in case. There is a pencil with you as well. So what we're going to do is take the pencil and the strip of paper, and we're just going to wrap the sheet of paper around the pencil, kind of a slight little bit of an angle that we're going to create a tube.
Okay,
so what we're going to do to make this,
like a little cone.
We're going to make a rocket. Yeah, exactly, like a little tube, a cone, and you should end up with kind of a tube that's wrapped around the pencil, like something like that. And I want you to put a little bit of tape at each end. So you should have a little bit of sellotape there that kind of that'll hold all of that in place. You can probably put a little bit at the middle as well if you need to.
Oh, I keep the pencil in, do I?
Yeah, I think when you put the tape on, that should make it easier to do that.
Okay.
If not, we can go back. That's all right.
Gotcha.
So then you can remove the pencil from the tube, and you were left with a tube. And already we're getting something that kind of resembles a rocket. Now, the good thing about this is you can design and put artwork onto it. Yeah, I know it's hugely complicated and complex, but rockets, the thing about this is that the fire comes out one end and the rocket goes in the other end. It's like Newton's third law of reaction, or motion. For every action, there's an equal and opposite reaction. So we have our tube that looks like a rocket, and at one end, probably the narrower end, I want you to take the top and just kind of fold it over on itself as tightly as you can, just for a little bit. So you're kind of folding over the top, so you're putting a cap on the top of it.
Okay, but I tape that down? No?
You don't need to. It should, if you fold it over nice and tight, I should be able to
So far, so good?
So far, so good, Tommy. This is going excellently. What I want to do now is, on your table as well, and with your sheet of paper, there should be small little triangles cut out. And with the remaining little bits of tape, we're just going to put them onto the rocket itself at the other end. So it's really starting to look exactly like a rocket. So if you put one side flat and you tape a bit onto it, and you put another one of the triangles.
Exactly like a rocket.
Well, I mean, Tommy, in your mind, you might think that this doesn't look like a rocket, but there's so many different types of rocket that this one, like yours, is just special and beautiful as well.
This is very much what the Irish space program.
Well, I mean, Irish Space Agency, we're looking to set one up. Ireland is about to launch its first satellite, AirSat, with Parallel, so it's a student-led project. So we will have our own first Ireland's first satellite. There are reasons to be hopeful.
It's good. I won't be involved in that. Okay. Well, look, I mean, it's not going to get to the moon, but
no. But we see this is perfect because this is part of the testing and exploring and tinkering. You're going to try things and see how they work out. The fins on the rocket are to help guide it and to start it spinning, because things that spin are more stable. If you ever see like an American football being thrown, it always spins and spirals. So that keeps it in the same plane. Okay. So with this now, you have a little rocket, and you should have a stripy straw. If you put the stripy straw inside the rocket, like so, that, aim it at the camera, and then give it a sharp, big blow and see what happens. Yes!
Did we get that? Success!
Yeah, look. Success, it's glorious. So
I thought I was going to have to use the immortal words, Houston, we have a problem there, but I was surprisingly successful.
Like, the thing about this is you've made a little rocket that launched. To add another little bit into it, you can either make it more attractive, like by drawing your own space agency onto it, or by reusing. And we try to reuse things as much as possible on this show because we try to be as sustainable as possible. Even like reusing the straw, reusing the rockets, but even reusing plastic straws that sometimes get thrown out. These ones have a bendy bit at the end. So what I'm going to say is if you put the straw or the rocket on the long end, and you have a bendy bit, you can look at working out angles. So by firing it at this way or slightly angling it up, you can launch it at different angles to see how it will go the furthest.
Well, I have a bendy one here.
A bendy one. So if you'd like trying it at a different angle, then go.
No. Well.
You see on the top. What's happened with that is
I knew we should have quit when we were ahead.
No, we're doing great. Last little bit. This is the other little bit of maths that I just wanted to show you finally.
Very quickly, Phil.
Very quickly, I know. Okay, so protractors sometimes are looking at working at angles. All I've done here is this example comes from Science Foundations Ireland Discovery Science and Maths, which schools use. There's lesson plans all over. Just Google it. So if you have an angles written out like this, and you have a plumb line dropping down, as you tilt this up, tilt it the other way, the other direction, you'll see that the plumb line matches with different angles. Yeah. And this is a great way to actually show to kids when you are angling at a particular angle.
And you change the angle of your launch then.
Change the angle of the launch, match it with that.
We have to leave it there, Phil. Folks, get sending in your pictures of you firing your rockets at your parents, especially when they're annoying you, asking you to do your schoolwork this morning. But thanks to Phil Smith for joining us as always. Right, after the break, lots more still to come. I'll be chatting to Ireland and Leinster rugby star Gary Ringrose.
Phil's Science Lab, sponsored by ESB's Generation Tomorrow programme. Check out esb.ie/Generation Tomorrow to start discovering.